Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 4, that is Measures of Dispersion, brought to you by Vitan Sir. In my previous tutorial, I completed the mean deviation. You can find that video link at the top of your screen. Now in this particular tutorial, which I have created at some extra length, I have covered two most important topics of this chapter. Number one is standard deviation and number two is coefficient of variation. Standard deviation is considered the best absolute measure of dispersion, whereas coefficient of variation is considered as the best relative measure of dispersion. We are going to discuss these two measures as well as we are going to solve two exercises concerned with these two different measurements. So this is going to be an extra long and extra informative tutorial. So I hope you guys enjoy it and study it properly and solve the sums in your notebooks. Let's start. Standard deviation. Now, the definition of standard deviation as given by Carl Pearson is the positive square root of the mean of the squares of deviations measured from mean, and this is denoted as small s. Okay, now this distribution, this deviation is explained as the positive square root for the mean of the squares of deviations. Now deviations, I think I have already explained the deviations from mean means observation minus mean, squares of these values and then divide it by number of observations and then find the positive square root. So this is a composite measure. It has a big calculation, but then again, because it has a big calculation, it is considered more important compared to other measures. If we don't apply the square root, if I don't root it, the measure what I get is called a variance. Now remember that if we just find the mean of the squares of deviations measured from mean, then it is variance, and then if I find a positive square root of the variance, I get the standard deviation. So variance is actually the square of the standard deviation. That means variance can be denoted as s square. So S is standard deviation and S square is variance. We will discuss it in future tutorials how to calculate variance. It is nothing difficult actually. Standard deviation is the most widely used measure of dispersion at the higher level of the study of statistics. Okay, and standard deviation itself is an absolute measure, and therefore the relative standard deviation, that is relative s, is standard deviation divided by x bar. Okay, so s upon x bar, standard deviation divided by mean. The relative standard deviation is also called the coefficient of standard deviation. As we all know, adding coefficient basically means that it's a relative measure. Now formula for standard deviation, usually we have same formula for whole data, but in standard deviation's case we have different sets of formulas in different conditions. I will explain them to you one by one. For ungrouped data, now we know that standard deviation is the positive square root of the mean of the squares of the deviations from mean. So it is going to be something like this: x minus x bar is the deviation, summation square is the sum of the squares of the deviations, divided by mean is the mean of the sum of the squares of the deviation, and then square root. So it is the positive square root of the mean of the squares of the deviations from mean. Now if the mean is in fractionals or the decimal values, that means I have to subtract a decimal value from my observations, then find a square of it and then add them up. That's a very long tedious work. So if my x bar is a whole number, I'm going to follow this formula. But if x bar is not a whole number, but x bar is a fractional value, say 2.3 or 4.5 or 6.73, something like that, So at that time, using this formula is a bit tedious, and in the rounding off of values you might make some mistakes. So I have some different formula here which you should follow in case x bar is a fractional value, that is summation x square divided by n minus x bar square. So in this case you don't find deviation, rather you just find the square of the observation directly, and then divide it by n and then subtract it using the square of the mean. Okay, so it follows the same purpose, your answer will be same, but this will be less tedious and less error prone. Okay, the third formula for the same ungrouped data belongs to the shortcut method. You know the d values we calculate, observation minus assume mean and all that. So of course here we have the d formula. The d formula is summation d square upon n minus summation d upon n the whole square. So in case our values are such or very big values that I want to reduce them to smaller values, I can calculate the d's from the x and then use that d to calculate the standard deviation. If we come across such a question, we will discuss this formula. But for ungrouped data, d formula is not used that much. Usually the regular formulas, the first and the second formula is only used for ungrouped data. The shortcut formula, the d formula, is not used. Moving on towards the grouped data. Now in the grouped data, because frequency is there, I am just going to add f after the summation sign, and that would be my standard deviation for the grouped data. Summation f into bracket x minus x bar square divided by n the whole root. Similarly, again if my x bar is in the fractions, then I'm going to use this formula here, that is summation fx square divided by n minus x bar square. And if all of my classes are with equal class lengths, okay, if it's a discrete data, then if all the discrete variable have a same difference, 5 5 5 10 10 10, or if it's a continuous data and all the class lengths are same, I can convert that data into again a d value. And if I'm converting into d value, it means I'm using the shortcut method, and if I'm using the shortcut methods, then the shortcut formula of standard deviation for the grouped data is going to be summation fd square divided by n minus summation fd upon n the whole square root, and out of the square root into c. C here depicts the class length. If it's a discrete data, the equal difference between the variables, and if it's a continuous data, then the equal class lengths of all the class, that is c. So at the end you have to multiply it using the c value, that is whatever it is, 5 10 15 20 100, whatever it is. So these are the 6 formulas which you need to remember for using standard deviation. Basically in textbook there are 9 to 10 different formulas given, but I have shortlisted them here. You just need to remember these formulas, and even then for ungrouped data it's okay if you don't remember the d formula. So just remember 5 formulas. Even if it's a lot, these are the least possible formulas which I can give you right now. Okay, so study them properly. Let's move on to the advantages and disadvantages, and then we will start with the sums. The advantages of standard deviation: its definition is clear and precise. All the observations are used in its computation, so it's a good measure. Basically, it's the most efficient measure of dispersion among all the measures of dispersion. It gives the best accurate answers. It is suitable for further algebraic calculations. That means if in future I want to use this data for a higher level of studies in statistics, I can use standard deviation there. It is most widely used measure of dispersion among all. So it is most efficient as well as most widely used. The disadvantages of standard deviation: its computation is of course complicated compared to other measures. For example, if you take a range, highest minus lowest, that's all. If you take quartile deviation, q3 and q1, that's all. If you take mean deviation, it is still a lot easier compared to the standard deviation calculation. But if you want a good measure, you need to calculate. It's simple. The extreme observations affect this measure a lot. Now this is one of the basic disadvantages which we should be worried about, that if in your data there is a observation which is too big, than other values, or there is an observation which is too small than other observations, then it will affect the value of the standard deviation and it might not reflect the actual situation. So you need to be wary of those kind of observations in your data if you are going to use standard deviation. It cannot be obtained if the classes are open ended. Okay, so if the classes are open ended, we can't obtain standard deviation because we need all the values, all the observations, so we can't use standard deviation in this cases. So let's start with exercise 4.4. There are 5 questions. All of them are of standard deviation, and even in some questions, coefficient of standard deviation is also asked. Let's solve these sums to get the idea of what is standard deviation and how to calculate it. First question. The marks obtained by 9 students in a test of mathematics is given below. We have to find just standard deviation from that. Okay, the data is here. And what I'm going to do, I'm going to present this data in a table rather than just writing them down haphazardly. I'm going to present it using a table. Marks 64, 63, 72, 65, 68, 69, 66, 67 and 69. What I'm going to do, I'm going to make a total of all these values, because just like in mean deviation, even in standard deviation, we have to start by calculating the mean, and then using that mean we have to calculate the deviations. So for calculating mean, I need the total of all the observations, and the total of all the observations here is 603. So let's calculate mean, which is summation x upon n, which is 603 upon 9, because 9 observations are there, 9 students are there. So the answer is 67 marks. Now here the mean is a whole number. Because mean is the whole number, I don't need to use that alternate formula where if mean is in fractions, what we do, etc. I'm just going to use the very first formula here. And in that formula, I need to calculate x minus x bar and then square them. Okay, I need to calculate x minus x bar. So x is the marks, and from each of the marks I'm going to deduct 67. So 64 minus 67 is -3, and so on. I hope you guys are already in 11, so you know how this goes. Okay, so all these values depict the subtraction of observations, and subtracting 67 from all the observations. We don't need to make a total here because we need the square of these deviations. So x minus x bar square, whatever values we have got in the x minus x bar row, we are going to square them. So 3 3s are 9. Every square is always positive, so negative signs are removed. 4 4s are 16 and 25 and 4 and 1 4 1 0 4, and then we make a total which is 64. Now we need to calculate standard deviation, and the formula which we are going to use is the very first formula, summation x minus x bar the whole square divided by n the whole square root. X minus x bar square, the summation value is 64, the n is 9 of course, and the whole square root. Now what we can do here, we can divide 64 with 9 and then find the square root. But just for this sum, I have rooted them first because both of them are perfect squares. So 64's square root is 8, 9's square root is 3, and 8 upon 3 is 2.67 marks. Okay, because this is a standard deviation and absolute measure, marks must be written, the unit of measurement must be written at the end. So my statement here will be that the standard deviation of marks obtained is 2.67 marks. Okay, so the answer for the first question, the standard deviation, is 2.67 marks. Moving on to the towards the second question. The number of cars coming for service in 5 service stations of a company are as follows. We have to find the SD of number of cars. Again, just the standard deviation we have to calculate, and the number of cars are 7 3 11 8 9. Again, I am going to present them through a table. The number of cars, of course, they are 7 3 11 8 9, and I'm going to make a total so that I can calculate the mean. Total is 38, so mean will be summation x upon n, that is 38 upon 5, because 5 observations are there, which is in fractions 7.6 cars. Now because the mean is in 7.6, that is fractions, I am going to use this formula, summation x square upon n minus x bar square. So right now I don't need to calculate x minus x bar and then square it. Rather, I just need a square of all the observations and then add them up. So I'm not going to deduct mean from all the observations. Rather, I'm just going to square the observations like this. X square, so 7 square 49, 9, 121, 64, 81, and the total is 324. I'm going to put these values in the equation. Summation x square 324 and is 5, x bar is 7.6. So 324 upon 5 is 64.8 and 7.6 square is 57.76, and your answer is under root 7.04, which is 2.65 cars. So the statement here that the standard deviation of cars coming for service is 2.65 cars. So depending on the question and depending on the mean, we have to change our formulas. Okay, I'm not going to use the shortcut method here because it is not required. Values are pretty small, and even if big values are there, we can pretty much ignore the shortcut method if we want, because there is no rule which says that compulsorily use this shortcut method. Okay, there is no rule such that we can use any method we want. If you want to use that x minus x bar square method in this sum, there is no rule against it, but using this particular method is better. That's why I have used it. Okay, moving on to the third question. Question number 3. The following data represents amount of deposits and number of depositors in a bank. Find coefficient of SD for the deposits. Now, if we want to calculate coefficient of SD, we need to calculate SD. So we need to follow all those usual steps and then calculate coefficient of SD as SD upon X bar. Okay, what is the data? Data is in a frequency distribution. The deposits are in 1000 rupees and then number of depositors, which is frequency. Okay, the data is a discrete frequency distribution because single values are given. Okay, and the frequencies are 2, 7, 11, 15, 10, 4, 1, and the total is 50. Now the thing which you should remember here is that these data can we can actually use the shortcut method here, because the deposits are 5, 10, 15, 20, 25, 30, 35. The difference is equal in all these values, but I want to start with a regular formula of x minus x bar, so I'm not using the shortcut method here. If you want, you can apply it, you can practice it using the shortcut method once this video is over and you know how to apply a shortcut method. But right now I'm going with the regular fx method, so I'm just multiplying the observations with the frequency. So 5 2s are 10, 10 7s are 70, and so on, because I need to calculate mean, and the total of all these observations, okay, will be 950. Now need to calculate mean, which is summation fx upon n. See how my formula changed a bit. Till now it was a row data, ungroup data, so it was just summation x upon n. Now this is a grouped data with the frequencies, so the formula is summation fx upon n. So you need to keep these things in mind whenever you are doing the statistics. The formulas keep on changing. 950 upon 50, which is 19,000 rupees. Because the value is a whole number, we are going to go forward with the regular formula, the very first formula, which is summation f into bracket x minus x bar whole square divided by n the whole square root. So for this purpose, first of all, I need to calculate x minus x bar, then I need to square it, and then I need to multiply it with the frequency. So 3 rows will be required. The first will be x minus x bar, that is from all the observations, all the values of the deposit, I will be deducting 19. So 5 minus 19, negative 14, 10 minus 19, negative 9, and so on. I hope you guys are getting where I'm going here. In the next row, I need to square these values. So x minus x bar square will be there. So 14, negative 14 square will be 196, negative 9 square will be 81, and so on. Okay, I am not just reciting each and every value here. I know you guys are that intelligent that okay, you will get what I am doing. Last, need to multiply x minus x bar square values with the frequency. So it will be f into x minus x bar square. So 196 will be multiplied with 2, 81 will be multiplied with 7, 16 will be multiplied with 11, 1 into 15, 36 into 10, 121 into 4, 256 into 1. And now this one I will make a total. Okay, so whenever you are doing these kinds of sum, don't just go and make total of everything. Okay, you just make a total of the values which you will need the calculation. This will save your time and there will be less errors in your calculations. Now I'm going to put this value here. 2250 is the summation f into x minus x bar whole square. So 2250 divided by 50 is the number of depositors, that is total of the frequency. So 2250 divided by 50 is 45 root, which is 6.71 thousand rupees. Now this is just the standard deviation. Next I have to go with coefficient of standard deviation, that is s upon x bar. The standard deviation is 6.71 and x bar is 19. So answer will be obviously 0.35. So the statement here that the SD of deposits is 6.71 thousand rupees and its coefficient is 0.35. Okay, I hope you guys got it properly. Let's move on to question number 4. The information of a profits of 50 firms is given below. We have to find its SD and we just have to find its SD and nothing more. Okay, the data this time given is profit in lakh rupees and number of firms, that is frequency, and it is a continuous frequency distribution. And as you can see here, 0 to 10, 10, 20, 20, 30, 30, 40, 40, 50, all the classes are equal. Now, because all the classes are equal, this time around, I'm going to use that D formula here. And because I'm going to use the D formula here, first I need to calculate the mid value. Now, mid value, which is X, I know you guys know how to calculate mid value, right? The middle value of each class, upper value plus lower value divided by 2, something like that. Okay, got it. So these are the mid values: 5, 15, 25, 35, 45. Now if I'm going to calculate D, I need to deduct a particular value from my observation and then divide it using the class length. Now from these mid values, I will take the middlemost mid value, which is 25, and deduct it from my observation and divide the answer with 10. Okay, so my assumed mean is 25 and my C is 10. Remember this thing. So naturally my answer will be -2, -1, 0, 1, 2. You guys are quite familiar with this system of answering in shortcut method from the third chapter. If not, just go and revise those things again. You don't need to make a total of D here because next you will have to calculate FD and then make a total of that. So frequency multiplied by D, 7 into -2, -14, 6 into -1, -6, 0, 12, 20. And when you make a total, you get 12. So now you need to calculate mean using the data here. X bar is A plus summation FD upon N into C. As you can see, because our question, the data is changing, the columns we are making changing. So with that, the formula of mean also changes. This is the third formula of mean which I have used in this tutorial right now. See how mean becomes a side character in the fourth chapter, which was just the main character in the third chapter. This is what is going to happen with even standard deviation when you move on to the next chapter, that is the fifth chapter, where even the standard deviation will be a side character. So learn these concepts very properly in the chapters where I am teaching you guys, so that in the future, whenever I am moving forward toward other chapters, you will remember those concepts very properly. A plus summation FD upon N into C. So A is 25, summation FD is 12, N is 50 and C is 10. And when I solve it, I get 27.4 lakh rupees. Now because I am using the shortcut formula, the shortcut formula states that I need summation FD square upon N minus summation FD upon N the whole square root into C. Now what does summation FD square mean? You can see here that summation FD square is just a square of D. F is one time and D comes twice. It is not a square of the FD row, rather it is just a square of D and then it is multiplied with frequency. So in that case we might have to prepare two new columns, but I have another idea. In FD column I have one F and one D. If I multiply FD with D, I will get one F and two Ds. So what I am going to do, I am going to calculate FD square by multiplying FD with D. What I am going to do, once again I am repeating, FD multiplied by D is FD square. FD multiplied by D is FD square. So FD multiplied by D, first thing negative 14, D is negative 2, so 14 2s are 28. Then negative 6 into negative 1, 6, 0 into 0, 0, 12 ones are 12, 22s are 40. Okay, so FD square is FD multiplied by D. Got it? Make a total of these values, you will get 86. Put all the necessary values in the equation here. FD square is 86 and is 50 minus summation FD is 12 upon 50 the whole square into 10. Now 86 upon 50 is 1.72, 12 upon 50 is 0.24, the whole square root into 10. Now 1.72 minus 0.0576 whole square root into 10. The 10 will be multiplied at the very end. Before that we have to solve the whole square root equation. So 1.72 minus 0.0576 becomes 1.6624 and square root makes it 1.2893, and when you multiply it with 10 you get 12.89 lakh rupees. So the standard deviation of profit of the firms is 12.89 lakh rupees. Okay, this was a bit lengthy question, a bit complicated question. Still, I hope you guys got it properly. Moving on to the last question of the exercise 4.4. Find SD of age of 125 persons living in a society and also find its coefficient, that is coefficient of SD. Okay, now the data is again given as age, years and number of persons, that is frequency. Now age is 0 to 10, 10, 20, 20, 30, 30, 40, 40, 50, 50, 60, 60, 70, 70, 80. That means again this is a distribution with equal class lengths, and number of persons is 15, 15, 23, 22, 25, 10, 5, 10. And when you make a total of this, you get 125. Next, mid value, that is X. So 0 to 10 is 5, 10 to 20 is 15, 20 to 30 mid value is 25, and so on up to 70 to 80 has a mid value of 75. Because this is a continuous distribution with equal class lengths, I am going to move forward again with the shortcut method of calculating D here. Because there is no most mid value here, I am going to take 35 as the assumed mean, and because class length is 10, x minus 35 upon 10. So 5 minus 35 upon 10 will be negative 3, negative 2, negative 1, 0, 1, 2, 3 and 4. You don't need to make a total of this. Multiply all the frequencies with the D, you will get FD. So negative 45, negative 30, negative 23, 0, 25, 20, 15 and 40. And now you make a total of this, you get just 2. Using this value, we have to calculate the mean here. So A plus summation FD upon N into C, which is 35 plus 2 upon 125 into 10, and when you solve this, you get 35.16 years. So now we have to follow the same formula which we followed in the last question. Summation FD square upon N minus summation FD whole square, summation FD upon N the whole square root into C. We are going to prepare this similar column, that is FD square, and FD square is the multiplication of FD with D. So negative 45 into negative 3 is 135, negative 30 into negative 2 is 60, negative 23 into negative 1 is 23, 0 into 0, 0, 25 ones are 25, 22s are 40, 15 3s are 45, 44s are 160, and when you make a total of all these values, you get 488. Now using the values FD square and FD in our equation, we get 488 upon 125 minus 2 upon 125 the whole square whole root into 10. 488 upon 125 is 3.904. Now 2 upon 125 and then the whole square is 0.000256 whole root into 10. What we are going to do, 904 minus 0.000256 is 3.903744 whole root into 10. After root it becomes 1.9758 into 10, it is 19.76 years. So the standard deviation of the data is 19.76 years, the mean is 35.16 years, and because we need to calculate coefficient of SD from this, S upon X bar is 19.76 upon 35.16, and your answer will be 0.56. So the statement here, the SD of age is 19.76 years and its coefficient is 0.56. So with this our exercise 4.4 ends, but as I promised you guys, I'm going to still continue with another concept, the most important, relative measure of dispersion, the coefficient of variation. I'm going to explain now. Coefficient of variation. SD is the best measure of dispersion, but it is an absolute measure, and hence we can't use it for the comparison between the two data with different units. We do have coefficient of SD for the purpose of comparison, but Carl Pearson has suggested a slight improvement in this coefficient of SD formula, and thus the coefficient of variation, which is denoted as CV, is considered the best relative measure of dispersion, which is as follows, where CV is S upon X bar into 100. As you have guessed, coefficient of SD is S upon X bar. CV multiplies that answer with 100. So we can say that CV is expressed in percentages and is best measure for comparison. We know that whenever we are in a doubt about the data or the comparison between two different types of data, we can convert those data into percentages and then compare those percentage values. So CV does the exact same thing. It converts the relative measure of standard deviation into percentages, so that based on those percentages we can make a comparison between two measures and know which has a more variation and which has a more stability. We will see how this coefficient of variation plays out using the exercise 4.5 right now. Exercise 4.5. First question. Price fluctuation in two types of shares is given below. Which type of share has more relative variation in price? Okay, so the question here is which type of share has more relative variation. Now share types are A and B. The A type has the values 321, 322, 325, 322, 324, 320, 323, 316, 319 and 318. Because I know I will be calculating mean here, I'm just going to make a total of this data. So the total of all these observations is 3210. The second set of data, because there are two sets of data given here, I have to calculate CV, or you can say mean and standard deviation and CV for both of them. The second set of data is B, which is 141, 146, 130, 146, 142, 145, 132, 134, 132 and 152. And again, as I know I have to calculate mean, I'm going to make a total, that is 1400. Now this data was already given in the question. Totals I have made, but rest was given in the question. I have divided them into two parts because I will be calculating in the between blanks the various measures according to the requirement. For the data A, I will start with calculation of mean. Mean is summation x upon n, where summation x is 3210 and n is 10. So the answer is 321. Now because the values are in whole numbers, I don't need to go for any shortcut or alternative methods. I can directly go for x minus x bar square. Now because x minus x bar and then squaring those values, why waste two lines? Let's just complete that thing in a single line. Okay, so from the observation deduct 321 and then square the remainder. 321 minus 321 is 0 and 0 square is still 0. 322 minus 321 is 1 and 1 square is 1. 325 minus 321 is 4 and 4 square is 16. 322 minus 321 is 1, 1 square 1. 324 minus 321 is 3, 3 square 9. 320 minus 321 is 1, 1 square 1. 323 minus 321 is 2, 2 square 4. 316 minus 321 is negative 5, negative 5 square 25. 319 minus 321 is negative 2, negative 2 square is 4. 318 minus 321 is negative 3 and its square is 9. and we will also make a total of these values to get 70. Now I need to calculate standard deviation, where I am going to use the standard method, summation x minus x bar whole square upon n, where I am going to put 70 upon 10, which is 7 root, that is 2.65 rupees. So the standard deviation of the given data for share prices of A is 2.65 rupees. So using the data of mean and standard deviation, I am going to calculate CV, which is s upon x bar into 100, 2.65 upon 321 into 100, which is 0.83 percentage. Okay, so the variation in the data of share prices of A is 0.83 percentages. We have to calculate more variation in price. So whichever percentage value will be greater will have more variation. Moving on to data B, we have to calculate mean for the data B, which is summation x upon n, which is 1400 upon 10, that is 140 rupees. Again, it's a whole value, so I'm going to use x minus x bar whole square. Now 141 minus 141 square 1, 146 minus 146 square 36, 130 minus 140 negative 10 square 100, 146 minus 146 square 36, 142 minus 142 square 4, 145 minus 145 square 25, 132 minus 140 12 square 8, sorry, negative 8 square 64, 134 minus 140 negative 6 square 36, 132 minus 140 negative 8 square 64, 152 minus 140 12 square 144. And when you make a total of all these values, you get 510, a bit bigger value. So it seems this will have a bigger variation. So the formula is summation x minus x bar square upon n whole root, 510 upon 10 whole root, that is 51 root 7.14 rupees. Now I'm going to put both of these values into the CV formula, that is s upon x bar into 100, 7.14 upon 140 into 100, which is 5.1%. As I told you guys, whichever value will be greater will have a greater variation. As we can see from the data B, the price of share B has more variation. So this is a kind of a 3 or 5 mark question. Okay, it seems more like a 5 marks question. So study these kind of things properly. You calculate mean, you calculate standard deviation, and then you calculate CV. Let's move on towards the second question of this exercise. The daily salary of administrative staff of two companies yielded the following results. We have to calculate that which company has more stable salary. Now stability and variations are two opposites. So if variation is more, stability is less. If variation is less, stability is more. So in the previous question, we calculated which has more variation. Okay, so the value which is greater will have more variation. That means the value which is smaller will have more stability. As you can see, they are the opposites. So the value which has more variation will obviously have less stability, and vice versa. So we are going to move according to that method here. The question is quite simple because data has been given directly. Company A has a salary 600 and standard deviation is 30. Company B has a mean salary 2100 and its standard deviation is 84. Now company A, we have to calculate CV to calculate this stability. So S upon X bar into 100, directly 30 upon 600 into 100 will be 5%. Okay, we know this. Company B, again CV is S upon X bar into 100, which is 84 upon 2100 into 100, which is 4%. So naturally the company which has less percentage of CV will have more stability, which is company B right now. So between company A and company B, the company B has less value of variation, which means B is a more stable company. So this is a kind of question which is asked for 2 marks because data is directly given. You just have to put it into the formula and get the answer. Question number 3. The coefficient of variations for two series are 30% and 25%. The SD are 15 and 9 respectively. We have to find the means. Okay, now this is going to be a pretty tricky, but I will make it easy for you. Series A, let's name them whatever we want. CV is 30%, standard deviation is 15. Series B, CV is 25% and standard deviation is 9. We are going to use the method of CV here. CV is S upon X bar into 100, where CV is already given, that is 30. S is 15 upon x bar into 100. I am going to change the places of x bar with 30. So 15 upon 30 into 100, the answer will be 50. So the mean of the first series is 50. Similarly, series B, where CV is equal to S upon x bar into 100, which is 25, equal to 9 upon x bar into 100. Change the places of x bar with 25, you get 9 upon 25 into 100, and your answer is 36. Okay, so with this, I end my today's lengthy tutorial, almost the double time of my regular tutorials. But thank you very much for staying with me for this long. Next time I will be solving one another point of this chapter, which might be the last topic regarding this. So wait for that. Write everything down in your notebooks. In case of any doubts, you can contact me. Thank you very much for watching this, and I will see you in my next video. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.